Okay, same balanced chemical equation here. The question is asking what mass of aluminum oxide is formed from 35 grams of aluminum and 25 grams of oxygen. So take both of those and convert them to moles. 35.0 grams of aluminum. 1 mole of aluminum has a mass of 26.98 grams. So 1.297 moles of aluminum is how much I'm starting with. I'm starting with 25.0 grams of oxygen. 1 mole of oxygen has a mass of 32.00 grams. So I'm going to start with 0.781 moles of oxygen gas. So now that I know how much of each reactant I have to go and figure out, is aluminum my limiting reactant? And in order to do that, I need to see, well, how much oxygen will I use to use up all of my aluminum? So 1.297 grams of aluminum, right? I'm converting reactant 1 to reactant 2. The balanced chemical equation tells me that nope, I'm not doing that one yet. The balanced chemical equation tells me I will need to use 3 moles of oxygen for every 4 moles of aluminum. And that in my calculator says 0.972 moles of oxygen, right? And then I always write this because students are like, what does this number mean? Needed to use up all of whatever the reactant 1 is aluminum. So this says I'm going to need to use 0.97 moles of oxygen to use up all my aluminum. I don't have that much oxygen. I only have 0.781 moles of oxygen. So 0.972 moles of oxygen is needed. That's greater than the 0.781 moles of oxygen that I have. So that means I won't be able to use up all my aluminum. The oxygen is going to run out first. Oxygen is my limiting reactant. So now I start with oxygen, 0.781 moles of oxygen, and I answer the question, right? Circle the do. What was the question asking me? What mass of aluminum oxide? Okay, balanced chemical equation tells me that for every 3 moles of oxygen, I will make 2 moles of Al2O3, aluminum oxide, and 1 mole of aluminum oxide has a mass of 101.96 grams. So that means I will be able to make 53.1 grams of aluminum oxide. Because after I make 53.1 grams of aluminum oxide, my oxygen will run out and the reaction will stop. And I will have some aluminum left over this time. Right? So write my sentence. The first thing I state is the limiting reactant. I can say amounts or not. I actually don't really care. 25.0 grams of oxygen is the limiting reactant. In order to use up all the aluminum, 0.972 moles of oxygen needed to be used. We only had 0.781 moles of oxygen. So it would run out first. And is the limiting reactant. Okay, if oxygen's the limiting reactant, that must mean that the aluminum is the excess reactant. How much aluminum did I start with? I started with 35.0 grams. How much did I use? I got to figure that out. I always go back to starting with my limiting reactant, 0.781 moles of oxygen. According to the balanced chemical equation, 3 moles of oxygen will require 4 moles of aluminum, and 1 mole of aluminum has a mass of 26.98 grams, and that will be, 0.104 grams of aluminum that is used. Okay, 28.104 grams of aluminum used. Look at significant figures, right? 25.0 is what I used. So those numbers, that's 25.0 grams of oxygen, has 3 significant figures. So this number should be rounded to 3 significant figures, which would be 28.1, which has 1 decimal place. So 1 decimal place minus the number that has 1 decimal place should have, in the end, 1 decimal place. I don't actually, round until the very end. So my unrounded answer is 6.895 grams of aluminum, and then I round that to 1 decimal place. So 6.9 grams of aluminum left over. Okay. If I look back at this problem, right, what did I start with? I started with 35 grams and 25 grams. So I started with 60 grams of material total. I have 53.1 grams of aluminum made and 6.9 grams of aluminum left over. I think I said 53.1 grams of aluminum oxide made and 6.9 grams of aluminum left over. So I started with 60 grams of materials and I ended with 60 grams of materials. That means that the law of conservation of matter was demonstrated.